Welcome back. So today we are going to talk about mainly the groundwater and its relation with the surface and further to some detail about the management part. Now, as we all know that the groundwater or the surface water moves through some system, and that system is mainly the fluvial system. So this is a picture which talks about or tells about some drainage network in a desert area, but this part we will be covering later when we will be talking about the drainage basins and all that, and talk about the different fluvial landscape. Moving further, water is ultimate resource. This we all understand, we know very well, and we always value it when it is required the most in summers. So as per the survey by UN, and this is an old survey, this is not the recent survey, but this survey was been done during 2013-14. It says that about 1.1 billion out of 7 billion people will lack access of safe water, and about 2.6 billion will not have access to adequate sanitation. It has been found that 80% of all disease in the developing countries are related to contaminated water. So this shows that how important is this resource, that is the water, which is the ultimate resource. Global demand is projected to grow by 40% in next 15 years. So if we say that this survey was in 14, so almost 5 years are gone, so more 5 years or more 10 years to go, and the demand will grow almost about 40%. So for each and every purpose we require water, and without water it is difficult to survive. So the demand is increasing per capita, but the resource, the source of the water is reducing, and that may be because of several other reasons of contamination of water and so on. Now, hydrological cycle, this is a part of what we were supposed to talk in under the atmospheric geomorphology. It's also an important point to be discussed here. So water is virtually vital for survival. Therefore, it is important to understand where to find the water. Now, where to find the water means which will be the particular area where we will be able to find the water. Surface water will be seen easily, but mainly for the groundwater. Subsurface water, which most of the areas in India, like for example the Indo-Gangetic plain, we remove or we take out lot of groundwater for irrigation purpose. So we need to know where exactly we will be able to find the water. So it is important to understand where to find water and how water supply cycle through the earth. So how this water is being supplied in a cycle through earth. So this is mainly we talking about the hydrological cycle, whether it is in the form of water vapor, in air, or precipitation, or on surface. So whether it is on surface or under surface. Hydrology is the study of movements and characteristics of groundwater. So how the groundwater moves, this we will try to look at in couple of slides. So the hydrological cycle has profound effect upon climate prediction, because if the climate change has been observed, then of course it is going to affect the hydrological cycle and definitely it is going to affect the groundwater also. So water in the environment, we'll see one by one. It appears in three states. Then we will talk about the hydrological cycle and consumers on earth. So moving to the first part of the water in environment, three states of water. So mainly we see in a gaseous state, we see in the liquid state and solid. So again, the transfer of from one form to another form is well known. So the water exists in three forms or three states: solid, liquid and gases, as ice, water and water vapor. Now during the transfer, latent heat is released, and this latent heat also plays a role where we were talking about the energy budget. So latent energy is released or absorbed as water changes from one state to another state. So whenever there is a conversion from ice or water vapor to ice, then the latent heat has been released. When there is a freezing from water to ice, then the latent heat is released. When there is condensation, again the latent heat is released. So during every process, either it is evaporation, melting or sublimation, the latent heat is absorbed and released in all these processes. Either it is freezing or melting. In terms of melting, the latent heat is absorbed. In terms of evaporation, the latent heat is absorbed. In terms of when you are having sublimation, the latent heat is absorbed. Whether it is released at the time of deposition from water vapor to ice, from freezing from water to ice, and then from condensation from water vapor to water. So water exists in the air in form of water vapor, cloud, fog and precipitation. Latent heat also contribute as one of the fluxes towards total energy budget of the earth. Now cycling of water flows into a reservoir includes inflow and outflow, and inflow equals to outflow. This one of the example of the reservoir input and output we were talking in the previous lecture. So this reservoir includes all the places that water is stored in and on the earth's surface. So water is cycled through the complete system, whether it is on the surface or subsurface. Distribution of water on earth. So if we take, we have 95% of salt water in ocean and seas, whereas hardly 4% is fresh water. The rest has been occupied as glacier or polar ice, atmosphere, lake and rivers, underground water and biosphere. So this is the distribution. So you can understand that how small quantity of water is available as a fresh water, which is important for us. So salt water 95% and fresh water just 4%. And what has been listed down here, the glacial, this is all the fresh water we are talking about. So if you, that is 4% total fresh water, and then this is definitely is the part of the fresh water. The glacier and polar, atmosphere, lake, rivers, these are all fresh water. So in total we have only 95%, only 4% is the fresh water and 95% is the salt water. Further, cycling of water is through the hydrological cycle. either through precipitation, infiltration and runoff. So, this is a typical hydrological cycle which we will be talking in the next slide. Evaporation, transpiration and sublimation and groundwater flow. So, cycling of water through surface or underground. So, hydrological cycle basically the global flow of water to and from ocean, land and atmosphere. And when we talk about the land, it also includes the groundwater. Water moves by evaporation, precipitation and runoff. Sun warms the surface, water evaporates from lake and rivers, ocean, plant and ground. The vapor rises into atmosphere from clouds. Water returns to the earth in a form of rain, snow or hail. Fill lakes and wetlands on surface, flows into river, ocean and recharge the water reservoirs subsurface. So, this is the complete cycle which we should know and which is important. Global transfer of water, if you look at, is one is the surface water, second is the groundwater. So, now if you look at this figures here, what we have one, so this is an annual flow of water on earth in thousands of cubic kilometers. So, one is evaporation from ocean to the atmosphere. So, this is the number which we have. This is very much similar to what we were talking about the energy budget. So, this is in thousands of cubic kilometer. So, evaporation from ocean to atmosphere, second is precipitation to ocean. So, one is from ocean to atmosphere and then second one is the precipitation to ocean which is coming back. Third is transfer of water from atmosphere to land. This one is third. So, transfer ocean to atmosphere to land, that is from atmosphere, that is from the ocean side through atmosphere to land. Fourth is evaporation to atmosphere from land. So, these two components are the evaporation to atmosphere, one is from ocean, another is from land. So, it is 72 and 505. Precipitation to land, this is number 5, and number 6 is runoff, this one is the runoff. So, runoff of surface water and groundwater from land to ocean. So, this is again very much similar to the balance water transfer, like similar to what we were talking about the energy budget. So, if you add a 1 and 4, it becomes 577, and then if you add up 2 and 5, it is the incoming. So, precipitation to ocean and 1 was evaporation. So, 1 and 4 is again evaporation to atmosphere from land, and 1 is evaporation from ocean to atmosphere. So, if you add 1 and 4, 2 and 5 which is coming in, it makes the same input and output, whereas water transferred to land from atmosphere is equal to water returned to ocean, that is 3 and 6. So, this is more or less similar diagram which explains the incoming precipitation and outgoing evaporation from ocean as well as from land, and precipitation coming in to land as well as to ocean in form of rain, and then transfer through ground, underground, subsurface, or through runoff on surface. So this is basically the hydrological cycle, or you can say geological cycle of water. So this is yellow one is showing outgoing and incoming precipitation by red. Now, one of the prime element responsible for life on earth is your water, and this is what we keep experiencing every summer, and mostly the villages where the water supply is very sparse. So these are the two pictures which shows the conditions in villages, and now slowly this is also touching towards the cities. So water is helpful in all ways. So who are the drivers of water consumption? Population, food consumption, economic policies including water pricing, technologies, increased efficiency, increased demand, lifestyle, recreation, societal value for fresh water ecosystem. So these are the main drivers of water consumption. So as we were talking about that, if we see the increase in the population, of course the demand is going to increase. Now, are we influencing hydrological cycle? Global warming resulting increase in temperature will causes higher evaporation from the ocean, will alter the hydrological cycle. So this portion, it suggests or clearly indicates that the global warming, which is again influenced by the humans, will increase the temperature, result into the increasing in temperature, and that will result higher evaporation from ocean and will alter the hydrological cycle. So the answer is yes, we are influencing the hydrological cycle. Global transfer of water in surface and again subsurface we are talking about. Then what are the factors that affects the transfer of water on globe? That is surface as well as subsurface transfer. Let's see quickly. So surface water, for surface water it is extremely important to know and understand the drainage basins and the major streams which are carrying the sediments as well as the water. So what it will result into the surface runoff. So when there is a precipitation or the rain water which falls on the surface, it will result into the runoff as well as erosion. So it will contribute to erosion, transportation and deposition. Then sediment transport by suspension or dissolution. Now this will depend on the factors such as volume, depth and velocity of the water flow. Drainage basin and watershed areas, then area of land that contributes, particularly this is the drainage basin that contributes to a particular stream or a river. So if you see on the right hand side, this is the basin A and basin B, and in the next slide we are going to talk about the lithology also. What is the importance of the lithology? Because that will also contribute in terms of the runoff, in terms of the erosion and then the sedimentation. The drainage density, if you look at on this basin A and basin B in the upper portion of both the basins, is higher as compared to the lower portion, because the part of the basin underlain by shale with high runoff potential and greater drainage density. This part, okay. And this one, that is the upper part, this one. So more of the drainage density has been seen in the upper part of that, and this is occupied by the shale. Now part of the basin underlain by sandstone with lower runoff potential and lower drainage density. Now this part is very important because when we are talking about the runoff, we were talking in terms of the hydrological cycle. So the yield of water or the supply in form of runoff will be controlled by the subsurface lithology mainly. So in one part, just looking at the morphology of the surface, you can easily make out that what is the subsurface lithology, or what are the rock types on which this river is flowing or the drainage exists. So this is very important for us, and this is the most important point which helps us in understanding the landforms also. So I'll stop here and we will continue in the next lecture. Thank you so much.